Hello and welcome. I'm Javed and this is my game Nebulaser. Nebulaser is a fast-paced, fixed-track, rhythm-based VR shooting game. You are traveling through a dense nebula while eldritch aliens come at you. The objective is to kill the enemies and survive until the song ends. You are equipped with two blasters, each of which can shoot three types of lasers, red, green and blue. Each enemy also has a color, however the enemy is immune to that color that it contains. So you can shoot a red enemy with a red laser, a blue enemy with a blue laser, and so on. The enemies also shoot projectiles at you and they can also crash into you. You must dodge the projectiles coming at them and kill the enemies before they crash into you. In this video I'll go through the following stages one by one and explain the development process behind each. First, the environment and design. This game was primarily inspired by Pistol Whip, in which you run and shoot enemies. However, I also wanted a mechanic similar to Beat Saber, in that you need a particular weapon for each particular block, in this case enemies. The game went through several different design changes. The first iteration was a more classic, vibrant alien world, a lush forest. However, this design posed some challenges. In this, the spawn locations for the enemies would have to be manually placed in the map. Also, the props like rocks and plants would mean that I would have had to write collision logic and different animations based on each position. Besides the time consuming for the level designer, this design would have also reduced performance due to the large amount of props. My solution to this was to go for a more open environment, so in the next design I had the player walk through the sky as the ground assembled itself under their feet. This design was more eldritch horror inspired than the previous classic alien setting. I modeled and added a huge orbiting eldritch being to add to the ambience. While this design does improve on the previous one, it still felt lacking to me, as besides the being floating above you and the ground, there was nothing for the player to look at. It felt empty. To solve this, I kept the openness of the previous design and made a new level that was more cosmic horror themed. I added some particle systems to act as nebulae and had the player travel on a small platform through them. I reused the previous eldritch enemy design I made and modified it to make more variants. These I used as the enemies. Thus the level design was complete. And now for tooling. To maintain productivity and efficiency throughout the project, I used Jira to manage my tasks, sprints, and to log hours. Git was used for version control. I used Blender to edit existing assets that I found to suit my needs, and also to create new assets as needed. Since this is a VR project, the project was developed using the Unity OpenXR package and the new Unity input system. Since the OpenXR package is so new, overcoming the lack of documentation and support was a significant challenge. For example, I wanted to pause the game when the player presses the pause button on the controllers. Problem: the input asset did not come with the pause controls mapped. In the end, I had to go on a huge journey trawling through the web until I found the answer in a random YouTube comment. All I had to do in the end was create the input mapping myself, drag it and drop it in the script, and add a delegate to listen to the event. It's a simple solution, but that's just how programming is at times. Enemies. The enemies in this game are pretty simple. I modeled an eye in Blender and got some particle system assets from the Unity asset store, and it was done. In the first iteration of the design, I had intended for the enemies to spawn, play some animations, and then crash into the player. For every spawn position, I had designed animations using the Unity animator. However, this implementation felt too lackluster and boring. Every enemy looked and behaved the same. I improved the enemies by removing the animator and doing the movement entirely in code. First, the enemy spawns at a predefined spawn point and then turns to face the player. It calculates the distance to the player and moves forward until it reaches a minimum distance. Then it shoots and waits for a few seconds for the projectile to reach the player. After that, it faces the player again and crashes into them. The enemy projectiles and their pathing was challenging to implement. This is because since the player is moving forwards at a constant speed, the enemy has to predict where the player is going to be first before shooting. Calculating this using trigonometry would result in too many unknowns, so I relied on an unconventional approach by defining a fixed time for the bullet to reach the player. Using a fixed time, I could use the equations of motion to find the position easily. This also came with the advantage that I was now able to control the bullet time, allowing easier balancing and making the game more enjoyable. Next is the blaster. The player has a blaster that can switch colors and fire different lasers. In the first design, the blaster was only in one hand, but I added dual wielding since it was more fun. Getting the bullets right was a challenge I had with the blaster. I experimented with several different ways. One, each shot from the blaster was a game object with its own collision detection logic using raycast. 2. Raycast from the blaster to check hit and also activate a particle system attached to the blaster. And 3. Raycast from the blaster to check hit and instantiate a line renderer between the positions. I went with the last approach as it is easier for the player to shoot that way. The other approaches weren't bad, but it just felt too difficult when the player and enemies are constantly moving. One last thing I did to make the shooting feel better was to use a sphere cast instead of a raycast. With this, the player has to be less precise, which makes for a better experience. And now for level design. The levels for the game are defined in the JSON files. Each file has the level length, the music, the spawn positions of the enemies. These enemies' positions are based on the distance the player has traveled through the levels. At the start of the game, the level is loaded and spawners are placed that activate based on player progression. While this did work well, the game felt too easy and wasn't as fast-paced as intended. To solve this, instead of placing one spawner at a spawn point, I changed the spawn points to be planes instead, and then place a random number of spawners at that point. The max and min spawners that can be spawned are defined in the level file. This change makes the game more dynamic since now the enemies come from very different positions and in varying numbers. Next is UI design. Since the player movement is restricted, the UI was simple. For the main menu, level selector, pause and game over menu, I just made a canvas that is activated and deactivated, fixed a distance away from the player. For the HUD that shows the score and the hits, I made a transparent holographic inspired canvas that is attached to the player's right blaster. It works very well. And now for the architecture. The game uses a top-down singleton based architecture. The number of singletons are kept to a minimum and most manager classes are instantiated and updated from one game manager class. The game manager class is a singleton that can be used by other classes to access data they need. To improve performance, the blaster lasers the enemies and the enemy projectiles use object pools. The level files and the music are stored in streaming assets. All in all, it works well and can be easily extended to add more features. And speaking of features, next up is future improvements. There are many different features that can be added easily with minimal modifications. New enemies, more colors, more lasers, and even more spawn positions. To add these, only the prefabs are necessary, plus add the spawn positions and colors to the values file and update the levels. Further expansion is also easy due to the well-defined architecture. And finally, to conclude, that's it for this video, and thank you for watching.